What's up, CalcuBots? In this video, we're going to talk about an advanced concept called the Intermediate Value Theorem. And I have it written right here on our board, and we're going to use it to solve some problems. So what is the Intermediate Value Theorem, also known as the IVT? If A and B are real numbers with A less than B, and f of x is continuous on the interval, on the closed interval a to b, then f takes on every value between f of a and f of b. So what exactly does that mean? I messed up right here. Should be gold. So what exactly does this theorem mean, right? So basically what it's saying is, if I have a function, let's say I have a graph right here, right? And I have this function graph that looks like this, right? If I put A right here and I put B right here, right? F of A is right here, right? That's f of A. And f of B is right there. So here is f of A, the function value at A. That's what that means. F of A means the value at A. Okay? And here I have f of B. Just like this. So what it says that if the function is continuous, then whatever f of A is, whatever number it is, all the way until f of B, then that means that I have to include all of these numbers, right? Let's just give it a number. Let's say f of A in this case is 0, right? Because it hits the x-axis. And let's just say f of B is, I don't know, let's just make it up, 4, right? F of B is 4. Then that means if I go from A to B, then I have to include every number between 0 and 4. So 0, 1, 2, 3, and every number in between. Not just 0, 1, 2, 3, but also like 0 0.5, right? 3.9, right? It's right there. Every number that is between 0 and 4, it has to be included if I'm going from A to B, because the function is continuous. All right? That's what that means. It may seem very simple to you. Well, of course it's going to have every number between f of A and f of B, right? But it's a very powerful theorem that allows us to come up with a lot of different things. But the caveat or the condition must be that A has to be less than B. In other words, I start from a low number and I go to a bigger number. And, right, the function has to be continuous. Continuous means that I can draw it for all intents and purposes. Just a little visual description is I can draw a function without lifting my pen. Continuous. Okay? It is continuous. Here's an example of a not continuous function. I go here, I stop, right? And then I go like that. This is not continuous because right here is a gap. And due to this gap, the intermediate value theorem is not, it does not hold. It's not true because it's not continuous. But if it is continuous, then the intermediate value theorem must be true. Okay? A function must be continuous for the intermediate value theorem to hold. That's a condition for it. You can't be saying, oh, see, the intermediate value theorem isn't true. Well, of course it's not going to be true in this case because the function is not continuous. It is true if the function is continuous. Okay? So in other words, the intermediate value theorem says no skipping. No skipping, no teleporting allowed. You have to go through every number that is there. Like the number line is continuous. From 0 to 1 is continuous because there's an infinite amount of numbers between 0 and 1. 0.1, 0.2, 0.0001, 0.000001, 0.00000001. Like we can go as small as we want, right? But the fact of the matter is it is continuous. There's no gaps. There's no teleporting. There's no skipping allowed. Okay, so we're going to use this to confirm the following, to solve this problem I have. We're going to use the intermediate value theorem to confirm that a given polynomial has at least one zero within the given interval. And this is our polynomial. Number one, we have f of x is equal to x cubed minus 9x. Okay, so we have a function, but we need now an interval, and our interval is the following: x equals -4 and x equals -2. Right? We can turn this into an interval like this. We can turn it into this, from -4 to -2, just like that. All right, so we're given the interval, right? You can rewrite the interval. So now let's use the intermediate value theorem to confirm if there is 1 0. All right, now I want to mention something really important. In order for a number to go through 0, it must go from negative to positive. For example, if I start at -2 here and I want to go to 5, I have to go through 0, right? Because 0 is like the barrier between positive and negative. It's what differentiates positive and negative numbers. A number less than 0 is negative. A number greater than 0 is positive. 0 is neither positive nor negative, right? It's that tipping point, right? It's that number that splits up positives and negatives. All right, it is neither positive nor negative, but it does help us identify when we go when we go from negative to positive, we have to pass through 0, right? If we just include integers, 1, 2, 3, 4, 5, like that, boom, boom, there, we have to pass it, and then we go. We cannot skip 0. We have to go through it because it's continuous. All right, no skipping allowed. So let's use our intermediate value theorem to confirm that there's at least 1 0. So remember, in order for there to be a 0, we have to go from positive to negative. So here, a is equal to -4, and b is equal to -2. A is always going to be the smaller number, all right? That's a condition right here. Look, a less than b. All right, just keep that in mind. A less than b. Remember that, okay? Now, we have to solve what f of a is and what f of b is. So here I'm going to solve what f of a is. So f of -4 is equal to, well, we have our function right here, -4 to the power of 3 minus 9 times -4. So let's crunch this number out and see what we get. So this will give us our f of a value, right? Which is the first one we need. We need f of a. Right? Luckily, I have a calculator. So let's do the quick math. -4 to the power of 3 is -64. So -64. And we have a -9 times -4, which gives me a positive number. And 9 times 4 is 36. So -64 plus 36 is -28. -28. Boom, right there. So we have our f of a value, and we have negative. In order for it to have at least one root, f of b must be positive. Okay? So now let's solve f of b. So f of -2 equals -2 to the power of 3 minus 9 times negative 2. Just like that. Okay? Oh, I forgot to state earlier. All polynomials are continuous. Okay, so I can just put that off to the side. Well, we'll do that in a bit. First, let me zoom out a bit, and let's solve this bad boy. All right, negative 2 to the power of 3 is equal to negative 8. And negative 9 times negative 2 is positive 18. So here we get 10. Look at that. We went from negative 28 to positive 10. Right? Then that means we have negative 28 here and positive 10. That means that we had to go through a 0 at some point, maybe here, right? We had to have, which means that by the intermediate value theorem, there must be a 0. So we just state it like this. By the intermediate value theorem, f of x has at least 1 0 or root, and just like that. Okay, I forgot to state it earlier. Like I mentioned, we have to state f of x is a polynomial and therefore continuous. Okay, all polynomials are continuous. So if it's a polynomial, it's continuous. We don't have to worry about that. Okay, there we go. That's how we solve it. We have to find f of a and f of b, and if it goes from positive to negative, from negative to positive or positive to negative, then we had to have at least 1 0. We crossed it. And let's graph it to confirm, okay? X cubed minus 9x. Let's go on Desmos. Let's graph it. X to the power of 3 minus 9x. Okay, and what was our interval? It was from negative 4 to 2. So I'm going to go here and I'm going to adjust the interval. Negative 4 to 2. In fact, it has 2 zeros. 1 here and 1 there. There it is. All right. Let me zoom out on the x-axis. I mean the y-axis so we can see it, the numbers. And let's go up to 12. There we go. There it is. So from negative 4 to 2. Right? The negative 4 is on the borders. Here, let me just draw x equals negative 4 and x equals 2. Were those the intervals we were given? Oh, negative 2. I'm sorry, guys. Negative 2. Always keep a lookout, okay? Minus 2. So that means I have to adjust this right here. Let's just increase it from negative 5 to negative 1. There it is. So from negative 4 to 2, there it is right there. There's our 0 right there. It had to have done it. All right? And here, look, we got 10. And if we zoom out, negative 28. Look at that. So from negative 4 to 2, we have 1 0 right there. We confirmed it by the intermediate value theorem. We don't need to graph it. We can just use the IVT to get it. Okay? All right. Let's move on to another example. So I'm going to erase all this and move on. So that was number 1. Let's go with number 2. And this time I won't forget to state it. And let's go with, I feel like that's going to screw me over. All right, number 2. We have, the same function. x cubed minus 9x. Okay, let me state it as f of x, so we can keep it. So f of x is equal to x cubed minus 9x. Only this time, the interval is given from 2 to 4. Instead of negative 4 to negative 2, we're going from 2 to 4. Okay? So a little different. 2 to 4. All right, cool. First and foremost, f of x is a polynomial and therefore continuous. I'm going to say cunt for now let's just write, I forgot what the abbreviation was for continuous. Therefore continuous. I'm just going to spell it out. No problem. Continuous. Okay? So let's apply the intermediate value theorem. Can we? Is A less than B? Yes, it is. Yeah. 2 is less than 4. 2 is less than 4, and f of x is continuous. All right, here we go. Let's apply the intermediate value theorem. Let's see if there is a root. So first, let's calculate f of a and f of b. So f of a, and here I'll have f of b. Okay. So f of a, which is f of 2, and f of 3, which is f of 4. Let's calculate this. So this time it's going to be 2 cubed minus 9 times 2. All right, I'm going to sneeze. Bless me, thank you. And now we're going to calculate f of b. I'm just entering the numbers first before I do the calculation. Minus 9 times 4. Just like that. All right, let's calculate. I know 2 cubed is equal to 8. Oh my lord, I forgot to change colors. So 2 cubed is equal to 8. 9 times 2 is equal to 18. So we get negative 10. All right, so we're at negative right now. All right, let me enter in my calculator to confirm. I'm confident in my ability, but it's never bad to check your answer, right? We all check our answers. Cool, negative 10 is correct. All right, so we have f of a is negative 10. So f of a is negative 10. All right, I'm gonna box it in green so that we know this is our f of a value, right there. All right, now let's do f of 4. Oh boy. 4 to the power of 3. I don't know, so let me do it. 64 minus 9 times 4 is 36. Okay, cool. So now we have 64 minus 36. And we get 28. So now, did we go from positive to negative? Yes, we did. We went from negative 10 to 28. So now, we're ready to state our conclusion. By the intermediate value theorem, f of x has at least one 0 in the interval 2 to 4. And there we go. Let's go back to our graph and let's see, all right, from 2 to 4 this time. So 2 to 4, so x equals 2 and x equals 4. So that's going to be over here. All right, here's f of a, and f of b is up here, 28, negative 10, or those are numbers, negative 10 and 28, negative 10, 28. All right, we're good. And there it is. By the intermediate value theorem, yep, it has one. Specifically at 3, 0, that's where our root is. But we're not being asked what the root is. We're just being asked to confirm that it has at least one root in the given interval. All right, let's do another example. I'm going to skip to a harder problem. Well, that one should do. Right, here we go. I'm going to erase all this, okay? So remember, before I erase, you have to state that it's continuous, because the function has to be continuous. Then you have to confirm that a is less than b, right? We have to fulfill the conditions on a to b, a less than b. And then we have to calculate f of a and f of b. And if it goes from negative to positive or positive to negative, then we cross the axis, we go through a 0, then that means that there is 1, 0. All right? Let's move on to the next example. Number 3. Number 3, all right? Let me zoom in. And let's go right here. I'm going to keep all this here so that we can keep track of, make sure we make no mistakes with the intermediate value theorem. All right, here we go. So number 3. I have the following problems. Let's go with this one. F of x is equal to negative x to the 4th power plus 4. And the interval we're given is from 1 to 3. All right, first and foremost, is a less than 3? Is a less than b? Yes, right? 1 is less than 3. So 1 is less than 3. So far, so good, okay? All right, we fulfilled the first condition. Now, is f of x continuous? The answer is yes. All right, so let me write it in white. F of x is a polynomial and therefore continuous. I'm going to cheat a little bit and put this, and therefore these 3 dots in the triangle formation means therefore. Okay, so I'm going to write that down. So this means therefore. Right, and therefore continuous. Right, all right, cool. So we have confirmed a is less than b, and we know f of x is continuous because it's a polynomial. And it's continuous on all values. So we don't have to worry about this second part where it says on the closed interval a to b. Well, because it's continuous. Right? Polynomials are continuous everywhere, from negative infinity to positive infinity. They're continuous. So the interval is not a stipulation for us. So now we have to confirm what f of a is and what f of b is. Let's get started. Now let's calculate f of a. So here we go, f of a, which is just f of 1, which is equal to negative 1 to the 4th power plus 4. And this is going to be equal to 1 to the 4th power is 1, so negative 1 plus 4. The negative's on the outside, so it's not affected by the exponent. Okay? Exponents only affect what they touch. So this gives me negative 3. Alright? If our f of b value is positive, then we can confirm it has one root by the intermediate value theorem. So now let's get f of b, which is 3, in this case, f of 3. So negative the quantity 3 to the 4th power plus 4. What is that? I have no idea. That's a tough one. Alright, I'm just going to give you the whole answer. So negative the quantity 3 to the power of 4. I'm doing it in my calculator, friends. Plus 4. I get, oh boy, it's a big number. I get negative 77. Oh boy. We ran into something, didn't we? Wait a minute. This one's positive. Why didn't no one tell me? Just kidding. Alright, so we went from positive to negative. Alright. So, there it is. This time, instead of going from negative to positive, we went from positive to negative. Then, now we can write our conclusion. By the intermediate value theorem, f of x has a 0 in the interval (1 to 3). There it is. Let's graph it. Negative x to the 4th plus 4. Negative x to the 4th plus 4. And what was our interval? It was from 1 to 3. We got big numbers, alright? So we're going to go from x equals 1 to x equals 3. Alright? Here you can see it, right? Hey, there it is, 3. And then the 77 is all the way down there. So, oh boy. Let's, right here, we're going to change this one. Let's go to negative 80. And it's right here at the bottom, right there. And look at that. Our 0 is right there. Look at that. Cool? Awesome, possum. Let's do one more example, and then we'll call it a day. Alright? I hope this is clear for you guys, but this is how you answer this type of question, okay? Alright, last one. Oh no, I erased part of my triangle. I mean rectangle. Oh well, it is what it is. Alright, last example is this one I'm gonna give you guys right here. F of x is equal to negative 2x cubed minus x between x equals negative 1 and x equals 1. Okay. So now I'm going to write this in interval notation. So I'm going to turn this right here. I'm going to take this and turn it into interval notation. And our interval is going to be negative 1 to 1. Just like that. Let me close it a little bit better so it's nicer, nice and clean. Just like that. Okay, cool. Let's get our a value going. So negative 1 is less than 1. So first condition fulfilled, a is less than b. Alright, we're good. We are very good. Alright, let's move on. This is a polynomial. So f of x is a polynomial and therefore continuous. And therefore continuous. Just like that. Alright, cool. So we have a less than b, and f of x is continuous on the interval a to b. Remember, polynomials are continuous everywhere, so the condition that it's continuous on the closed interval from A to B is fulfilled. Then f takes on every value between f of A and f of B. So now we have to check if it goes from positive to negative or negative to positive. And if it does, then we do confirm that the polynomial has a 0 somewhere in this interval. So now let's calculate f of A. I'm going to do f of A all green so I don't have to be alternating the colors. So f of A is this one. So negative 2 times negative 2 times the quantity, negative 1 cubed, minus negative 1, just like that. And here we have f of B, which is just f of 1, which is equal to negative 2 times the quantity 1 cubed minus 1, just like that. Alright, let's start solving this bad boy. Negative 2 times negative 1 to the power of 3 is equal to negative 1. And minus a minus is a plus. Negative 2 times negative 1 is equal to 2 plus 1. So f of negative 1 is 3. I'll check it graphically, so I don't want to do it on my calculator. But I'm confident in my numbers. Alright, 1 to the power of 3 is just 1. And negative 2 times 1 is just negative 2. Minus 1 is negative 3. Hey, look at that. We went from positive to negative, right? So then there must be a number between negative 1 and 1 that f of x will give me 0 because we went from positive to negative. And remember, no skipping. That's what continuous means. No skipping, no teleporting, no gaps. So let's graph it. Let's graph our function. Minus 2x to the power of 3 minus x. And let me just make sure I copied it right. Minus 2x to the power of 3 minus x. Alright, we're good. And our interval was from negative 1 to 1. So I'm going to make x equal negative 1. And I'm going to make x equal 1 here. And there we are right there. We're zooming in right here. Hey, look, 3 and negative 3, and we crossed it right there. There it is. There it is. That's the intermediate value theorem in action. Just like that. Boom, boom. It went from positive to negative, which means we did cross it. We went from positive to negative, which means we did cross it because 0 is between those two numbers. Alright, let's write our conclusion and we're done. I'm going to go here so you can see the conclusion very nicely, okay? Alright, let me type it actually. You know, I feel cool today. Alright. By the IVT, f of x has at least 1 0 in the interval from negative 1 to 1. And we're done. That. Oh, we can say then by the IVT, f of x has at least 1 0 in the interval from negative 1 to 1. And there we have it. That's how we do it. I hope this was clear to you guys. I hope you guys can apply it on your own exercises. Feel free to ask me questions. Feel free to send me messages, leave a comment. If you guys need more clarity or any more examples, I'll be happy to do so. And that's it for now. Peace.